Good morning, it's me, Mr. Trio. I'm back again for another video in geometry. Today I'm going to be looking at different, calculating the lengths of different segments and chords and secants and tangents and all that and lines. So we have three different formulas we're going to look at, and it's kind of some oddball formulas that are rather hard to remember. So hopefully I can go through these, make sense of them, and make something that sticks when it comes to how to remember this. The first one we're going to look at is chords. So if I have a circle and I have two chords that intersect, those two chords will then break each of those into smaller pieces. And the formula for calculating any of these pieces within that segment is to multiply the two parts together and then make it equal the other two parts for the other chord. The second one is if I have two secants, or lines that go through a circle. When I go to work that one out, what I'm going to be doing is taking the part on the outside, multiplying it by the sum of the outside and the inside, and then making it equal to the other secants outside times the inside and outside put together. And the last one I look at is with the tangent. So on the tangent, because the outside length and the entire length are the same number, you're basically going to be multiplying it by itself. You're going to be squaring it. And then on the secant side, you'll be just doing the same as before. You'll be taking the part on the outside and multiplying it by the sum of the outside and inside. All of which I'm going to go through in the next few minutes in this video. So look at how I do these, maybe take notes of exactly how these formulas work. They're not so much formulas, so much as a pattern, because what letters you assign to what are not really set like a normal formula. It's more or less just a kind of pattern in which you multiply that out to get the answers. All right, so in my first example, I have two chords that have intersected in a circle, and I'm trying to find the missing segment marked X. So what I do is I take that particular chord and I take and multiply its two segments, X times 12, and I set it equal to the other chord that has a 3 and a 16. So 3 times 16. Well, 12 times x is 12x, and 3 times 16 is 48. Divide both sides by 12, and the missing segment, marked x, would be 4. And just so I'm clear about the fact that what I'm saying here is that these two products, according to the rule, the product of these two and the product of these two is equal. It does not by any means imply that this segment is the exact same length as this segment, because that's not true. 4 plus 12 is 16, and 16 plus 3 is 19. They're not the same length. It's their products that are the same. So when we plug in 4, 4 times 12 is 48, and 3 times 16 is 48, so I know it's a true answer. All right, the second example, I'm looking at what would be two secants. These are lines that are going through a circle, although I didn't extend them in the other direction. There are lines that are passing through a circle called a secant. Well, the formula for this, and I kind of write it down like this, my shortcut way is the outside times the whole equals the outside times the whole. And what I mean by that is if you take the part on the outside of the circle and you multiply it by the whole thing, you should be equal to both. The other one should be equal just the same. So if I take, for example, this segment here 6, and I multiply, I say 6 times 6 plus 18. 6 plus 18 being the whole segment there is equal to 8 times 8 plus x. Well, as I start to work this out, I'm going to see a few things that I might notice a couple things, like in 6 and 18, I can put them together and make that 24. And over here, I can't put 8 and x together, but I can at least do the distributive property and say that 8 times 8 is 64, and 8 times x is 8x. So as I take the next step, I can try to simplify again, and knowing that 6 times 24 is 144. And then again, bring it down. Well, it's just a two-step equation at this point, because I've multiplied it out. All I need to do is minus 64 from both sides, and I get 80 equals 8x. Divide by 8, x's are equal to 10. So plugging that in, it seems legitimate, it seems reasonable, it's a positive number, it's not an extremely large or small number. Seems reasonable, and if I multiplied it out, I could see by plugging that back in that it would make these two things equal. All right, my last example, I'm going to do one that has a tangent and a secant, but because sometimes they have different variations of this problem and this problem, in which sometimes we have the variable on the outside, and that actually makes the problem a lot more difficult, and I'll show you why in a second. But I'm going to basically do this problem and this problem with the exact same method, or at least logic, and then I'm going to take the part on the outside and I'm going to multiply it by the sum of the outside and the inside. So I'm going to multiply it by x and 9. And then over this one, the part on the outside is 6, but the whole segment also happens to be 6. So what I'll end up with is 6 times 6. Well, I can't put these two together, but I can do distributive property, and I can say x squared plus 9x, and then 6 times 6 is 36. Well, right there I should start to realize something's going on here, because these last two problems seem to work out really easily with a little bit of adding and subtracting, divide by a certain number, and I get the answer. However, on this one, because x is on the outside and I multiplied it by another x, I ended up with a square, which makes what's called a quadratic. And what happens when you have a quadratic is a lot of times you have more than one answer. You can end up with two answers on a quadratic, and the catch here in geometry is that most of the time one of those is no good. So as I look at this and I realize this is a quadratic, I'm going to move to my best method, or the easiest method I can think of, and that would be to do what's called factoring. So to do that, I got to move everybody to one side of the equation. So I'm going to take 36 away from here and move it over here, and set it equal to 0. And to factor, what I'm basically trying to do is trying to figure out what two things multiplied together to make this quadratic equation. So if I break it down, or at least try to before I have to go to the quadratic formula, maybe I'll get lucky and it'll just factor. I start by looking at the end of the problem and say, all right, is it possible that I have two numbers that multiply to 36 but subtract and give me 9? And in this case, that's a possibility, because 3 times 12 makes 36, and 12 minus 3 makes 9. So I actually got lucky and can factor this problem. I don't need to do the quadratic formula, it's just a factoring. It's going to be 12 and 3. Now the trick is figuring out which one's which. Because I have a negative 36, one of these two numbers has got to be negative, because it's a positive times a negative that makes a negative. And like clockwork, a bell rang during the middle of this video.
Caleb Brady, please come to the front office.
Caleb Brady needs to go to the
please
front
come to the front office.
Either way, I'm not making this video again. So, well, I know that I got one that's got to be positive and one that's negative. And because the 9 is positive, that tells me the larger of the two factors has got to have the positive sign, because positive 12 and negative 3 make positive 9. Well, since these are both set equal to 0, and if I say x plus 12 equals 0, and I take 12 from both sides, x is actually equal to negative 12. On the other one, if I set x minus 3 equal to 0, add the 3 to both sides, x is equal to 3. Well, I know that this is the only legitimate answer. It has to be that x is equal to 3, because there's no way that I can have a segment that's negative 12. You can't have negative length. So in this case, x has got to be equal to 3, and that pretty much wraps it up. But I did want to try to put a problem where I had x on the outside so that we could see that when the variable's on the outside, we might end up having to factor, or actually we always will. Whereas on the other one, with the whole number, or the 8 being on the outside, we did not have to factor. All right, I hope this helps. Thank you. Bye.